Good evening. I did it again. It's not the evening, it's the afternoon. I don't know why I do that every time. All right, quick sound check on the audio and video front. I'm probably never not going to do this again because when it happened, it was just so painful. So let's see. Testing, 1, 2, 3. It's not coming through my AirPods. Testing, 1, 2, 3. Cool. Okay, yep, it's working. Things are in sync. We're all good. Happy Thursday. I'm getting started a little later in the day here than normal. My day kind of got away from me. That happens from time to time. You know, you set out with the best intentions to have a schedule for the day, and then you know your schedule kind of gets away from you. It happens. It's something that happens. What are we doing today? Okay, what we are doing today is we're gonna set up rate limiting for our API for our alt text project. So if you're new here or you haven't been following along, I've been working on building this little tool for myself on stream that will help me generate alt text for my social posts. And I've had no less than 2 people tell me this is a overly simple use case and that I should just use the Claude or ChatGPT app, which is, I mean, everyone's entitled to their opinion, but this tool is specifically designed to solve my problem. So, you know, I think it'll be useful. I think I'll get a lot of use out of it. Not everybody agrees with me. That's okay. But we have tests. We have our endpoint that generates the alt text. We have a few to-do items like we have a few to-dos around find grep to do. We have a few, like we have a to-do around file validation, like the size of the file validation we need to take care of. There's some to-dos around like specific provider implementations, but I'm gonna kind of ignore these for now because I'd like to just get to a point where we can actually use this thing from a client and we can come back and fill in the gaps when we'll implement some other providers beyond Gemini. So, but today what I want to do is I want to get rate limiting in place, because once that's in place, I'm comfortable then getting this Dockerized and getting this deployed somewhere. So how do you add rate limiting to a minimal API? So in the past, like .NET 7 and before, like the very first API I built with .NET, they did not have a built-in rate limiter, if I remember right. So let's go minimal API rate limiting. But now they do. So yeah, here we go. Here's the announcement. I think this was .NET 7. Yeah, .NET 7. So in .NET 7, they introduced support for rate limiting just out of the box. Before, there was a third-party app. There was a third-party app that I used. I bet I can find it on my GitHub. There was, I can't remember the name of it. Yeah, this was one of the first APIs I built in .NET. I think this is .NET 7. I think this may have been .NET 6 originally, and I've upgraded over the years. But there's a package in here. Let's see if I can find it. This ASP Net Core Rate Limit. This was like a third-party package that people used to use to do rate limiting. So NuGet. So this was a third-party package, but now there's built-in support. You can do concurrency limits. You can do it based on a token bucket, fixed window. You can do a sliding window. And they kind of explain this all in this announcement post. But there's also good documentation on it too. So let's search for minimal API rate limiting. There should be some docs. Here we go. Here's some docs. So what we want to implement, or what I want to implement, is I want to implement a fixed window limiter. And I want it to just be global. I just want a global. I don't want to specify this on a route basis. But I also want, so you can have rate limits, right? But then if you do this, like if you do this right here that they're showing in the docs, that makes it global for your whole application. Or I guess I should say, that makes it, when you apply that policy to an endpoint, that's a global policy. And so that fixed rate limit is not partitioned amongst your users, right? So you can create partitioned rate limiters, which then say, okay, like if we were doing it based on user, we'd be able to say, user 1 can make 10 requests an hour, user 2 can make 10 requests an hour, versus kind of that non-partitioned, which would be everyone can only make 10 requests an hour, right? So if let's say like 2 users each make 5 requests within an hour period, they both get rate limited, and I don't want that. So, and I also don't have identity as part of this API because I don't need it. So we can't use identity, so we're going to use IP addresses. And I think they have an example here that specifically shows that. And I've implemented this before on another API. Yeah, so here's an example of like the partition limiter, right? And this is global, so this is being applied to all your routes. I basically want to do this, but I don't want to do it on the user agent. I want to do it on the IP address. I know there's an example in here somewhere. Yeah, I don't see it. Okay, let's go to one of my old projects. I know for sure I implemented this on one of my projects. Let's see. I think I implemented it in Onyx Graph. Oh, no, come on, yeah, here we go. This is what we want to do. So let me put this on the other screen. And let's get to work implementing this so that I'll just reference it from this other screen. But I want to be able to reference it a little bit easier than that. Sometimes I have too many windows. Too many windows. Anybody else have that problem? Too many tabs, too many windows? All right, so to implement rate limiting for a minimal API, this is kind of my approach to implement a global limiter that'll affect your whole API. It's not going to be per route specific, but this is kind of where I usually start. And so what you're going to do is, the first thing is you're going to probably want to make a check to see if you want to actually add the rate limiting based on whether it's in production or not. So that's usually what I do. So, because there's not really a sense in having this enabled in a development environment, so I'll usually say if app is environment.is production, I don't want the exception handler there, Copilot. I want to say app.use rate limiter, like that, which is great, but we obviously don't have any rate limiting configured or defined. We don't have any policies or anything like that. So now what we're going to do is on the app up above, on our app builder, and specifically on our builder's services, we're going to invoke a method called builder.services.add rate limiter, just like this. And then that's going to take a lambda, which has some configuration that we can do. So let's make our lambda and fix our formatting a little bit here. And we are going to set this to o.global limiter. And then we are going to call, not new rate limit options, we're going to call partitioned rate limiter. And we are going to say create. And I think I'm missing a namespace, so let me add that real quick. Using system.thread.rate-limiting. And then we're going to call create our limiter. And here we're going to define it. So this takes a lambda as well, which is going to be an HTTP context. And actually, let's just do CTX for brevity. And then we have to return something from here. And what we're going to return is we are going to return our limiter. So we'll say rate limit partition dot get fixed window limiter. So this is going to be a window that's basically a certain amount of time you can make this many requests. But obviously we want to partition this, so we need to first define a partition key. And so let's just say for now we'll just put global, right? Which means everyone's going to end up getting put into that partition, but we're going to actually turn that into an IP address in a second. Then we're going to have a factory, and that factory is going to take a partition, and that partition, what is that type? That partition is a string, so that is going to be our new fixed window rate limiter. And then we need to define some options for that. Whoops. Not rate limiter, we want rate limiter options, like that. And then we're going to come down here and we're going to define our options. So in this case, I'm going to say my permit limit is, let's just set it to something real low so we can test it. Let's say it's like 1. And then let's set the queue limit. So this is how many it will queue up for us. We'll set that to 0 because I don't want it to do any. And then let's set the time span so that we can test it. Let's set the time span for kind of an egregiously long time. Let's just say time span dot from minutes is 5 or something like that. Oh, sorry, it's not time span, it's window like this. And it wants us to use an expression body, which is fine, we can do that. Okay, we can do that same thing up here. But now I'm gonna want to mess with the formatting here to make this a little bit more readable. So O goes to a global rate limiter. It's going to be set to a partitioned limiter, and that's going to be created from the context like that. We can make this static. We can make this static. And let's move that in there. And then this wants actual types. So this is actually gonna, this is gonna require 2 types, which is gonna be HTTP context and string. Okay, so now we'll permit one. So basically, we're gonna permit one request every 5 minutes. And then also let's remove our check down here for now. Let's actually remove this so that the app just always uses rate limiting. And I'm pretty sure rate limiting has to be called before the map endpoints method. I think that's an important thing they call out in the docs. Let me look back here. Use rate limiter. Let's see. Yeah, right here. It's just, it says use rate limiter must be called before use routing when rate limiting endpoint specific APIs are used. So that's just an important thing to know. If you're going to rate limit specific endpoints, the order of that, of those method calls is important. Okay, so now what we're going to do is, should we test this real quick just to make sure it is actually rate limiting? We haven't got the IP address right yet, which we can use the context to do that, to get our IP address. But right now everyone's just getting put in the same bucket. So while this is a partitioned rate limiter, it's essentially not, because the key is going to be the same for everybody. So let's write that out. And let's go ahead and test this. So let's open up a new console window here. We need to disable readline. Let's cd into software projects, altgen again. We'll say .NET run. Source, altgen API, and we need to give it a project flag. Like that. And so hopefully this starts up okay. And then we need to open probably Postman, right? We can do some testing here. Oh, I hear my kids coming home from school. Forgive me if there's a lot of noise in the background for a minute and a few minutes. Let's see. So let's open a new Postman tab here. And we're going to make a post. We're going to make it to HTTP endpoint localhost 7297 at the generate endpoint. And our body is going to be form data, and we're going to need LLM. I forget what our request needs to look like. Yeah, I wrote the API and I don't know how to use it. This is a common thing. So we need a provider key. We need a provider key, a provider key, and a file. So I'm not going to actually, I'm going to give it a bad key, but we will set provider to Gemini. We'll set provider key to something that's fake. Hey guys. And then we'll turn this into a file, and this key will be file. And we'll give it test image. Okay, so now we should do, this should return a 400. Oh no, return to 500. Huh. Wonder why. But now if I send another request, I think I should get rate limited. Yeah. So it's 503, means it's unavailable, right? But I think we can change that. I think that's the default, so we can actually change. We can actually change that. But it is working. The rate limiting is working. So let's shut down the API real quick. And let's go back over here to our program. And we can actually define some additional pieces on this options. So now we're going to convert this to a not lambda, or I guess to a non-expression body lambda. So go here, tab all that in. Tab all that in. So now what we're going to do is we're going to come over here and we're going to say, okay, O dot rejection status code is going to be status code 429, and then we'll say O dot on rejected, and so this is a property that you can set to basically tell your API how to respond when the rate limit's hit. So we're going to say static context equals, yeah, that Copilot, that should work. And then we need to return a completed task. Return value task completed. Oh, and then we also need to say, instead of doing it like that, we need to say if context.lease.try get metadata, if that has a metadata name dot retry after, then we will outvar the retry after and we'll add it to our context. But this is not an HTTP context. We need to say context.http context dot response, like that. And then this is going to be x, we're going to do x retry after. And then this is going to be retry after. We'll say var retry date equals date time dot UTC now. And this should just be retry like that. And then this needs to be converted to a string. And specifically, we want to use the O format. And if I remember right, the O format let's see. What doesn't it like about this? With what? What does it want? Culture info dot invariant. Invariant culture. There we go. That's a little long. Let me put these on separate lines. So now we have a retry after header being appended to our response, and now we're also using 429 instead of instead of 503. Okay. Whoops. Yep. And we need to add this here. And these are off file tab. Okay, so let's restart our API. Okay, let's go back to Postman now. This is going to give me a 500. But if I send another request, it should give me 429. 429. 429. Okay, it's not. So why is it not? What did I mess up? use rate limiter. Oh, it's not even reaching that piece of code. It's tripping up on something else. Timespan.format. Input string was not in a correct format. That should be right. ToString. Let me look. ToString C# invariant. Oh, this because I don't want to use the time span. I want to use retry date. So shut that down. Start it back up. Go back to Postman. We'll save this. Well, we don't need to save it. We'll just resend it. It'll fail because something's going on with my Gemini call. Then I'll send this again, and it gives me 429. So now I've rate limited. And then I should have a header with the date or the time at which we should be able to retry and get a successful request, which is about 5 minutes from when I just made my request, which is awesome. Very cool. However, we still have this problem where we're using this global, this is hard to demonstrate at the moment, but we have this global key. So if I hit the API twice in these 5 minutes, I've essentially rate limited it for everybody, because now everyone's going to get put in that global bucket, and we don't want that. So what we need to do is we need to get the IP address for the person making the request and use that as our partition key. And so the way we're going to do this is we're going to use our context. So we'll say context dot HTTP context, and the first thing we're going to look for is we're going to look for the X forwarded for, right? Because this is gonna run behind proxy when I deploy this. So the first thing I'll look for is the X forwarded for header. Yeah, X forwarded for. And then if that's not there, we want to look for the remote IP address. So we'll say context dot, oh, also this is not the right context. Then we'll say, if that's not true, let me put this on the new line. If that's not true, then we'll say context remote IP address. And if that's still not true, we will say unknown. And if you're an unknown person, you're going to get bucketed with all the unknown people, unfortunately. Oh, and this doesn't need, this is an HTTP context. This is a direct HTTP context. So we'll say HTTP context. Oh, and this needs to be .toString. This is deference, so we need to do an optional chaining. And then this is not literal unknown, but a string unknown. And that'll just be our global bucket if for whatever reason we can't resolve these two. It would be weird if we can't resolve either of these IP addresses. So now our rate limiting should work the same. So if we start up our API again, we call it, it should fail, which we know it's been failing. I don't know why it's failing, but now it should send another request and it should rate limit us now. And it should just keep rate limiting us for, you know, until that retry time expires. Okay, cool. So now we have rate limiting set up, which is good. That was like the next thing I really wanted to get accomplished. Oh, you know why this is failing? You know why my requests are failing is because I it's most likely because I'm giving it a bogus key. So that's why. I should probably. Why is my API having trouble shutting down? There we go. I should probably. Like it would be helpful if if somebody sends a bad key and the Gemini API responds with the bad key, it would probably be helpful to pass that info along to them so that they know. So I'm going to add that as a to-do. But before I do that, so that is at a high level, right? Very quick and dirty. That's how I set up rate limiting for minimal APIs. And I just use the built-in system.threading.rate-limit package. And this is basically generally how I set it up. Now, there's all kinds of different things you can do with rate limiting, like we talked about, where there's different types of rate limiters. There's different so there's different types of rate limiters. You can rate limit per route. You can add multiple different types of rate limiting policies to your application and apply those to different endpoints so that different endpoints have different rate limiting. But this is what I use now for minimal APIs, and this is how I set it up. This is kind of the starter point of where I set it up. And so you could theoretically, you could have a situation where you have kind of a global limit on your API, say like 10,000 requests an hour, but then maybe for even more sensitive endpoints, maybe like logging in, resetting passwords, that sort of thing, you could set a more granular API or a more granular rate limit to maybe like only be able to, attempt to log in 5 times within a 1 minute thing, something like that. So you can get really granular and make this work however you need it to work. But this is how I do it. I hope it helps. Hope you'll be able to put that to use. All right, so now that we have the rate limiting in place, let's go ahead and change these values to something more realistic. So probably permanent limit, let's say, I don't know, like 100 in an hour. Which 100 an hour is, let's see, if we did 10 a minute, that would be 60, no, 10, yeah, 10 a minute. 10 times 60. Oh, that's 100. So we don't want to do 10 a minute. I mean, the way I foresee this being used, I don't think someone's gonna use this 100 times in an hour. So that's where I'm just gonna start with 100 an hour. And then I'm gonna come down here and I'm gonna wrap this so that this is only actually active in the production environment. Put that there. Yeah, that looks pretty good. And let's add another to do, because there's definitely stuff we could do better. Let's see, it's in here, and then in here. I think right here what we should do is to do propagate the error response from Gemini in the exception, whoops, in the exception we throw here. and but I need to figure out need to figure out how Gemini returns errors. I don't know how they do that. I haven't looked at that, so I need to figure that out so we can translate that over here. Okay, and I think now what we want to do is we want to try to Dockerize this API so that we can run it in a container. So it'll run in a container behind a proxy on a server is my plan for this from a deployment perspective. So what do we need to do that? What do we need to do to Dockerize this? Alright, so how I usually Dockerize APIs is I create a new Docker file in my directory. So we're going to create a Docker file. And then we're going to come to this Docker file. And the first thing we're going to do is we're going to create a setup stage. And we're going to have this base image be the SDK, because you need, your base image has to be the SDK because you need to build, right? You need to build the project. So this is going to be .NET, and it's going to be SDK, and it's going to be 9.0, and we're going to call this as setup stage. This way we have kind of a multi-stage build here. Our worker is going to be as GitHub Copilot guest. It's going to be app. That's pretty standard. The first thing we're going to do is we're going to copy not everything. We're just going to copy our CS proj. And the reason for that is because the way Docker builds images, it builds them in layers. And so if anything hasn't changed at that particular layer, it'll cache it, which will make building the image quicker. So this way we'll copy the CS proj, and that way it'll essentially cache all of our dependencies. And then we'll run .NET restore. Whoops. .NET restore. Like that. And then we'll copy the rest. And obviously there are things here in our project we don't need to include, and in order to exclude them, we'll just create a Docker ignore file and tell them to exclude it. So I'll go ahead and do that now, and I'll say .docker ignore, and this file Docker will use to say, okay, I won't copy any of that stuff. So we don't want to copy in our app settings because we're going to use environment, but we don't have any app settings at the moment, but if we did, we would just use environment variables to override them. So app settings.json needs to be ignored. The Docker file itself can be ignored. We don't need that in it. I think that's all for now. I think the rest of it can all be included. Back to our Docker file. Okay, now what we want to do is we want to actually have a build stage. So in our build stage, what we're going to do is after we've restored, we are going to say from setup stage, and then we are going to run publish release, and I'm not going to say app publish, I'm going to say dist like that. And it could be, I mean, these folders could be whatever you wanted the out folder to be. That's up to you. It's just this is what I normally do. Okay, then we'll come down here, and this will be our actual final stage. So this will be the actual, what ends up being our actual image. So we'll say from mrc.microsoft.com, and we'll say .net, and we're going to use the ASP.NET image, but instead of 8, it's going to be 9.0, and we'll say as, actually let's make this production stage. It's a little bit more accurate. Production stage. And the reason why there's two different base images, one for production and one for the setup, is the setup image has the whole entire .NET SDK in it, which you need to build the app, but you don't need the entire SDK to run it, which is why you use this smaller base image, which is the ASP.NET image there that I've picked there. And then our working dir is going to be our app, and that is going to be that's just basically the same as the application up here, or the same as the folder that we defined up above. And then what we need to do is we need to copy from our build stage, right? Because in our build stage, we generated this dist file, or this dist folder. And so what we need to do is we need to copy from build stage. We need to copy from app dist to our root. And then we need to expose our default port, which is going to be 8080. That's the default port that the API will start on when we run this command. And so this is going to be .NET. And then we need the DLL. So my DLL is going to be called altgen.api.dll. So that's my entry point. You can write that out. And now we should be able to build the image and actually run it. Do I have Docker running? I don't have Docker running. Let me start up Docker here. But now we should be able to actually give this a go. Looks like it's starting up here. It's probably taxing my machine quite a bit. Let me I'm actually gonna bump up I think I have it set to silent right now. I'm gonna bump it up to turbo. There we go. Okay, so I don't have any containers running right now, as you can see. But what we're gonna do is we're gonna build our image and then run it. So we're gonna cd into source altgen API, and then we are gonna say, I always forget the commands, so I always have to look them up. Docker build command. This is typically the one I go to. Docker tag and publish an image. Yeah, so this is the basic command, but we want to be able to tag it with a name. So where's our tagging? So we'll say Docker P is going to be altgen API and then the source. So this should build our image. And if I wrote that Docker file right, hopefully it works. So it's already at our production stage, so that's good. Oh no, that's our setup stage. Now it's at our build stage. So now it's and production build. Okay. So now we should be able to say Docker. Is it Docker list? I can't remember what the commands are. Docker help. Docker. I want to list images. There we go. Docker images. Docker images. So there's the one we just built. Altgen API. So now what I should be able to say is I should be able to say Docker run. Docker run altgen API. And there it is. The 8080 port. But that's the port in the container. So if I go to Docker, you you can see, that's a funny name, Naughty Jepson. But you can see this doesn't have any ports mapped to it. So I actually need to map some of my host ports to my container, to the port that the container is actually running on. And that I should have done in the Docker command. So docker run -- help. It's a dash. What's the port? Let's see. Shift find port. Expose. No, I don't want to expose. Oh no, so it is the P command. It just stands for something different than port. Publish a container's port to the host. Okay, so, and I always forget to, I think it's docker run -p, and I think I give it my host port, and then I map that to my container port, like this. And then I can say alt-gen API. And then if I go back to my, see now, so now I have two instances running. I have this guy and this guy. This one I can actually delete. So this one should be listening on HTTP 66. So let me open that. Let's see. Let's try to make a request to it here. Yep, and so you can see there's the request, and obviously it failed, and it failed because the key I'm giving it's bogus. But it's listening. And actually, let's see if I can I add a key here without exposing myself? I think I can. Hold on. Let me take this off screen. I'm going to add a variable here. Let's see, new collection. We'll call this alt-gen. Create, save. Put that in there. And then a variable, we'll say Gemini API key. And then I've got that over here, so let me grab that real quick. App settings, no, it's my test settings. So yank, let's close that again. Let's go back to my program. And then here, it's gonna be that. Just like this, just like this. Okay, now what I should be able to do, just type Gemini API key there. I don't want to expose that. Oh, not as a param in the body. That. Well, it failed, but I'm not sure why it failed. Could be something with their services up, but in any event, we now have our API running in a Docker container. And now all I have to do in order to deploy this is I just need to build a GitHub workflow that when I merge to main, I build a new version of the image, I push that image to Docker Hub, and then I log into my server, pull that image down, and run it, essentially. That's basically going to be the idea here. But this is how I approach Dockerizing an API like this. This is kind of, obviously this could be much more complex if you have a lot of other projects in your repo that need to also be included as part of your Docker file. Like if you had a class library or some other some other libraries that you needed to include as part of this Docker file to run your API, this would be a little bit more complex. But if you're just building a single API and all the code you need is in that single project, this is kind of a good place, I feel like, to start from setting up kind of a base Docker file so that you can run your API in a container. So I hope you find that helpful. I know it took me a little while to figure out how to do this, so I just want to make sure and save you some time, share out my learnings in hopes that somebody else might be able to benefit from it. Okay, I think that was our 2 to-dos for today. Was we were gonna Dockerize it. No, we were gonna add rate limiting, which we did, and then we were gonna Dockerize it, which we did. So, and all under an hour too, which is pretty productive for us, considering I usually move pretty slow. So we'll write that out. I do kind of want to figure out why. I do kind of. Let's figure out why my API is responding with a 500 though, because I don't know why that's happening, even after I gave it a proper key. So let's open up our project here real quick. We'll do this real quick, and then I'm going to wrap up. So on our generate endpoint, let's go down here. Let's go into our service. And in our service, let's set a breakpoint here. And then let's start up our API. So .NET run -- project source. Okay, so it's running. My debugger should be listening. Oh, actually, no, it's not, because I need to run it with the debugger attached. That's my fault. So I don't need to run it from here. I need to run it from over here. So what do we push? We're going to say BC. Rebuild first, yes. Path is going to be, what is it? Bin, debug, net 9, and then altgen DLL. Why'd that fail? Oh, because I don't want the DLL, I want to build the, so hold on, space, BC, yeah. Why is it? Whoops. I guess I've never used this since I added that rebuild functionality. Path to CS proj. Huh. Wonder why that's failing. In any event, I'll just build it over here. .NET build source. Okay. And then over here, we are just gonna say, we're just gonna say space DC no net 9 alt. Okay. So it's listening. You can see my debug console there. I'm gonna send a request to it. What's it listening on? 5,000? I wonder why it's listening on local host. 5,000. And send. Okay, there we hit our breakpoint. The model is overloaded. Please try again. So it's still overloaded? This is the same issue we ran into yesterday. Gemini model overloaded. Huh. So Google API Studio. Let me see if I can just generate a response in the studio. Let me try to use, I think I'm using 1.5 Flash. Okay, summarize this. Yeah, 1.5 Flash seems to be the issue. The model I'm using seems to be the issue. Pro fails too. Okay, what about the 8 billion parameter? Okay, so that seems to work. Does 2.0 Flash work? Okay, let's change our, let's stop that and let's just use a different model for the time being. So this is 1.5 Flash, so let's try using 2.0 Flash. Okay, and then let's build this again, which maybe that's something I should put in the configuration as the model that we're using. Maybe we should even let people pick the model, configure the model. I don't know. That's, I guess that's a feature we could add. Where's program? So we could say providers, Gemini service. Maybe this is configurable or configurable by the user via request. Yeah, let's rebuild it. And then let's run it. .NET run, project, source, API. So now this is going to be HTTPS 70007297. And let's send this. Well, let's save it, but let's generate. Okay, and let's go ahead and send this and see what happens. Nice, there we go. Yeah, Baby Yoda with its pale blue skin and large black eyes holds a small brown, which is exactly what the image is. Let me get the image that we were using so you can see. Where is that image located? I think it's in a Postman folder. Postman, files, yeah. So this is the image we sent. That's the image we sent, and that's the alt text we got back. So that's, yeah, there we go. We're working. We're live. Okay, cool. You want to try running this in our container too? Let's try running it in our container. So let's close this. Let's go back into source, AltGen API, say docker build d AltGen API. Okay, it should rebuild this. And see how these were cached? These layers were cached because nothing changed about those layers, but something did change about our build layer. Okay, so that's been, now we say docker run -p, and we'll do 666 goes to 8080, and we want to run AltGen API. Okay, and then let's see, our Docker containers over here. And that's running there. So now we should be able to come to our generate request and modify this to be 6666 and send that. Oh, we're not running on HTTPS, so send. And there we go. A medium shot depicts Baby Yoda, a character from the Star Wars spinoff, and so we're getting a little bit of variety in that in the text it generates, which is what we want. But for the most part, right, it's capturing the essence of the picture. Cool. So yeah, so now we're ready to maybe next time what we'll do is we'll set up the GitHub workflow so that we can deploy this to a server and actually have this publicly available, and then we can start working on a client to call it. Yeah, that's what we'll do. All right, that's gonna do it for me. Hope you guys had a good Thursday. I'll see you next time.